Hey, what's up everybody? My name is TooTallToby, and in today's Solidworks step-by-step tutorial, we're going to try to create this model right here. Now, this model comes from the TooTallToby website, and it's part of the free challenge that you can do without even signing up for an account. So you go to TooTallToby.com, you say try as a guest, and here you can say, I want to try the sample and reveal drawing. And right away you can jump in and you can try this model. You can see here that what we do at TooTallToby.com in the Practice Models app is we challenge you to figure out what is the mass of this part in X grams, and then you're gonna enter that answer down here. And so this is a really fun way to learn CAD, to get better at CAD. And today we're gonna go through and we're gonna try to model up this part. But the thing I wanted to let you know about is that you may be brand new to SolidWorks, maybe you're brand new to the world of 3D CAD, and I've released a 30-minute quick start, totally free. I'll include a link down below. And if you are brand new to SolidWorks, you might want to go through that 30-minute quick start. It really reviews a lot of best practices and kind of navigation shortcuts in SolidWorks, and I think that you're going to find it to be very helpful as you're going through this tutorial, especially if this is your first time working in SolidWorks, trying to create some models. So with that in mind, let's get into it here. We're going to try this very first challenge at TooTallToby.com. We're going to say click here to try the sample and go. So the question here is, what is the mass of this part? And you can see there's some instructions. We're going to start out by opening SolidWorks. We're going to model this part using millimeters. We're going to assign ABS as the material, and then we're going to calculate the mass of this model. Now, even though the clock is running, what I like to do before I get started actually creating these models is kind of think through the model and come up with a game plan. And this is always a good idea when you're trying to take something either from the real world or from a napkin sketch and turn it into a SolidWorks model. You want to kind of think about what the process is going to be. And one of the first things you're going to think about is, where should the origin be located in my model? Because the location of the origin is going to help you with a lot of downstream applications. And I think in the case of a model like this, where you've got a rectangle, especially when you've got these center line symmetric notes, which means that everything that's on one side of the center line is going to be symmetric to the other side of the center line. Whenever you've got a shape like this, even if it's just a rectangle, even if it didn't have these notes, you're probably going to want to put the origin right here, right in the middle of that rectangle. And the reason that is a kind of a general rule is because that's going to leave you with a plane running right through the center of the model. Now, this plane could be used if you create some geometry on one side and then you need to mirror that geometry over to the other side. But it could also be used in an assembly to center this part on other parts. And this is something very common that we do. We take two parts with center planes and then we make those planes coplanar, and that aligns everything in your assembly. So putting the origin right in the middle of a rectangular base, almost certainly going to be a solid plan when it comes to 3D modeling. So once you decide where the origin is going to be, the next thing you want to think about is, what's my very first sketch going to look like? And I think my first sketch is going to be on the top plane, and it's just going to be a rectangle here at 30 millimeters by 55 millimeters. So I'm going to start a new sketch on the top plane, create that rectangle, and then I'm going to extrude that up to a height of 7 millimeters. Now, that's going to leave me with kind of a rectangular box with sharp corners. So the base will look like that, and then the side walls will look like this. And then I'm going to need to kind of round off those corners with a radius of 8 millimeters. Well, the tool that we use for that is going to be called a fillet feature, and we're going to apply that to all 4 corners. And then the final challenge that we run into with this model is we need to hollow this thing out. So we've got this note here that says 1.6 wall thickness typical. So what typical means is, unless otherwise specified, you can expect that the wall thickness throughout this model is always going to be 1.6. So this will be 1.6, this will be 1.6, this will be 1.6. Even the floor here will have a wall thickness of 1.6. And that's what typical means when you see that on a drawing. So centerline symmetric, typical, these are common notes that you'll run into on engineering drawings, and now you kind of know what those mean. If you like that overview, be sure to hit the like button. And I know we've kind of burned off a couple of minutes here on the tutorial, but I just think it's always good to come up with a good game plan. Now, on that note, you can see here that this challenge has an average solve time of 2 minutes and 28 seconds. So if you wanted to, you could solve it here with me, and then you could go back, and then you could start the challenge again just to see if you can beat that time before you actually submit your answer. So let's do that now. Here we go. 3, 2, 1. Go! All right, what is the mass of this part? We got ourselves a game plan. Let's get into it here in Solidworks. So I'm going to say new, and then I'm going to choose to begin a new part. Now, your new part window might look like this. It might look like this, the library of templates, or it might even look like this coming off of the home screen. Regardless of where you start, just make sure that you choose a part file. And then we need to make sure that we specify the millimeters as our unit type. Well, you can do that really quickly down here in the corner. So you can see that down here in the corner, we've got our unit type, and it's currently set to mmgs. That's millimeters, grams, seconds. And if it's not set to that, just hit this little flyout menu here, and you can set it to millimeters. All right, now, if we think about our game plan, we said that we're going to start with a new sketch on the top plane. So you can see here in SolidWorks, we've got our different planes listed over here: front plane, top plane, right plane, and then you get the origin down here. This is all part of the Feature Manager design tree. That's this first tab here, the Feature Manager design tree. So we're going to choose the top plane. You just click on it, just one time, click on it. And then we're going to go up here to this tab that says Sketch. So you notice here we've got this tab up at the top. This is called our Command Manager, and this is the Sketch tab on our Command Manager. And then we're going to actually click on this button here, which is for New Sketch. I know it's a little confusing because this is called Sketch and this is called Sketch. You just want to remember this is the tab down here. So you click on the tab, you click on the button for sketch, and where is this sketch going to land? It's going to land on the top plane because the top plane is currently selected. So now we are in sketch mode, and it's really important to know when you're in sketch mode, and you can tell you're in sketch mode because of the red origin. Anytime you see the red origin, that means you are in sketch mode. Okay, when you see the red origin, you're in sketch mode. So if you go up here to that button that you pressed to begin the sketch and you click it again, now it says exit sketch, you see the red origin goes away. And then if you click on the top plane and then you click on the sketch command, now you are back in sketch mode and you're sketching on the top plane because you pre-selected the top plane. Very important to know when you're in sketch mode. So now we're going to click on the rectangle command here on the sketching tab. So sketching tab is here and rectangle is right here. We're going to click on the rectangle, and you'll notice here that we've got these different options for the rectangle. You've got these 5 different options. So if we choose the first option, that's called a corner rectangle, you'll see that you can just kind of sketch a rectangle anywhere. Okay, that works okay, but really we want this rectangle to be centered. So we're going to change to a different rectangle type, but before we do, we want to get rid of these existing rectangles. So what you can do is you can hold Control and press Z. Control Z is the undo command, and if you press it again, Control Z, and you press it again, Control Z, and you press it again, Control Z, you can see that you can back yourself out of all those rectangles. Now, are we still in sketch mode? Yes. How do we know? Because of the red sketch origin. But if you press Control Z too many times, you might have actually bumped yourself out of sketch mode, and you can see the red sketch origin goes away. And so we need to get back into sketch mode. So what do? We pick the top plane, we click the sketch icon, and boom, we're back in sketch mode. So right now what we're doing is we're looking at sketch mode. We've got the red origin. We're also looking at the Feature Manager design tree. So that's this information down here. But if we click the rectangle command, a different tab shows up in the foreground. So now you see, instead of looking at the Feature Manager design tree, now we're looking at this tab here. And this tab is called the Property Manager. And this is a really useful tab. It helps us manage the properties of different elements, different things that we're working on in SolidWorks. And currently we're looking at the properties of this rectangle, and we're going to choose to create this type of rectangle here, a center point rectangle. So we choose that second type of rectangle, and now we're going to take our mouse out to the origin, and we're going to single click and move our mouse and single click again, and boom, there we go. We've created ourselves a very nice rectangle there right on the top plane and centered on the origin. So now we're going to hit escape. You can hit escape a couple of times. Now, when you hit escape, do you exit sketch mode? No. Right? No, we don't exit sketch mode. And the reason we know that is because the red origin is still displaying here. So we're still in sketch mode. And now what we need to do is add some rules to this rectangle. See, when we created this rectangle, some rules were created automatically. Like this line here has a rule that says it has to be horizontal. This line here has a rule that says it has to be vertical. But we're missing a very important rule, which is the size of the rectangle. And so we're going to add that rule using the command smart Smart Dimension. So if you move your mouse up here onto your sketching tab, you've got this icon up here for Smart Dimension. You're going to click on that Smart Dimension command, move your mouse out onto the screen. One thing that I find to be pretty useful is if you look at the mouse, you can see that next to the mouse, there's a little dimension icon. And now if you press escape and then move your mouse around a little bit, you'll see that that icon goes away. So I use that a lot. I use that feedback that shows up on the mouse. So now I know I'm no longer in the dimension command and I can move this around. But if I click the dimension command again, you can see there's a little dimension icon there next to the mouse. So we're going to add a rule here, and based on the drawing, let's look at the drawing for a second. The rule should be that the rectangle is 55 wide by 30 tall. Okay, easy enough. So we added we began the dimension command. You can see the mouse still has the dimension. You can see the button is also pressed in. That's another place that you can look up here on the toolbar. You can see that the button is pressed in. So we're in the dimension command, and now to add this dimension, we're going to make 3 clicks. So the first click is going to be over here on this line. The second click is going to be over here on this line. And then the third click is going to be up here in space. And remember, if you mess up at all, you could use Control-Z or you could press Escape and then you could start over again, click the button again. But here's what this will look like. We're going to click once here on this line, once on this line, and then click once up here in space. So we're in the dimension command. We click here. We move our mouse over. We click here. We move our mouse up. We click here. We let go of our mouse. And now we can type in. So you let go. And now you can go over to your 10 key on your keyboard and you can type in 55, enter. And boom, you've added that dimension of 55 millimeters. And now if you were to 3D print this part out, you know that you're going to be getting the correct size from the 3D print. So now if we take our mouse and we move our mouse a little bit, we can see we're still in the dimension command. This is going to be another 3-step process. Step 1, we're going to click on this line. Step 2, we're going to click on this line down here. And then step 3, we're going to click out here in space. Okay, so another 3-step process here. 1, down here. 2, then the third step's going to be over here. 3, that positions the dimension. And then you let go of your mouse, and then you're going to type in 30, enter. And whoops, I typed 37, right? So what could I do? I could just press Control-Z, Control-Z, and then I can type in that dimension again. Okay, so Smart Dimension, come out here, click once, click twice, and then come over here, click in the background, let go of your mouse, 30, enter. Okay, of course you could change the dimension. We'll learn about that in a future tutorial though. For now, just use Control-Z. It's good to learn how Control-Z works. You're gonna use it a lot, trust me, throughout your SolidWorks career. All right, so now we've created this geometry, and this geometry is just a rectangle. It's just a flat rectangle. If you press straight down on the wheel, you know, like the wheel is a button, and then you move your wrist around, move your mouse around, you can rotate this model. So you can see that this is just a sketch. It's just totally flat. Another good shortcut to know is you can press Control-7. Control-7 will take you into an isometric view, and once again, you can see that this rectangle is just flat. So once you press Control-7, what you can do is you can go up here to Features. Here's the tab for Features. You can go up here to Features, and then you can choose to extrude this rectangle into a solid. So we go up here to Features, Extrude, and once we choose Features, Extrude, you can see that we are now in the Property Manager again. This is what I like. I like the Property Manager. This guy is our friend, the Property Manager. So these are the properties for this boss extrude. And so what we want is underneath Direction 1, okay, if you need to, you can expand this. Make sure this is set to blind. And then down here for the depth, we're going to look at the drawing, and the drawing says that that depth should be 7 millimeters. So we're just going to go into that box there where it says 10. You can double click in that box, and then you can let go of your mouse. You can type in 7, and you can press Enter, and that updates the preview. And then without touching anything else, you can press Enter again. Boom, there is your first solid part. Congratulations in creating this first solid part. And so now what we can do is we can use our mouse to manipulate the view. You can press straight down on the wheel like a button. We talked about this before, and that lets you rotate the view. You can take your finger here and you can roll the wheel, and that lets you zoom in SolidWorks. And then if you lose the part, if it goes completely off the screen, you can hold Control and press 7, and that brings you into an isometric view. But you can also use Control 1 for a front view, Control 2, Control 3, Control 4, Control 5, and Control 6 for all the standard views, and then Control 7 again to get to an isometric view. Now, when it comes to scrolling with the mouse, what you can do there is if that scroll direction feels backwards to you, if you're coming from a different program and scrolling goes the opposite way, you can go up here to the top of the screen in SolidWorks and you can click on this icon here, and that's going to let you adjust your system options. So if you click on that icon, the little gear, then what you can do is you can go in here and you can choose search options, because there's a lot of options over here in this list. Okay, there's a lot of options here that you can adjust, and you have no idea where the option is for mouse wheel zoom direction. So just go in here to where it says search options and type in mouse, M-O-U-S-E, and then you can see here that in the return from the search, you can say reverse mouse wheel zoom direction. And it is kind of cool to know it's here in system options under view, and then it's this very first option here. You check that option on, hit OK, and then zoom and see if that zoom feels more natural. And if you like that pro tip, be sure to hit the like button. Be sure to let me know down in the comments. That's definitely a fan favorite, the ability to change the mouse wheel zoom direction. It will make you much more efficient, especially if you're used to it zooming the other way. So now let's press Control 7, just so we're all looking at the same thing. And now we're going to round off these corners here. Now to round off these corners, we're going to use the command fillet. And I just want you to see that the fillet command does exist on the Sketch tab, but it's not really appropriate for us to use it here. It might be appropriate if we were still sketching that rectangle and we wanted to add those rounded corners in the 2D sketch. But what we're trying to do is modify the solid. So whenever you're trying to modify the solid, you're going to go to the Features tab. So here's the Features tab. And then once you click on the Features tab, you're going to click Fillet here. So we're going to click the Fillet command, and once again, here he is again, our old friend, the Property Manager. So you see why I like the Property Manager so much. The Property Manager helps us manage properties, in this case, the properties of the fillet. So you want this to be manual. You want to be using the first type of fillet. Leave this box empty for now. And you want to make sure that full preview is turned on. Make sure that full preview is turned on. Once you click on that option for full preview, if it was set to no preview or partial, set that to full. Then you can go down here in this box and you can double click. That's the box for the fillet radius. And that radius is going to be 8, and just press enter once. And then you can go into this box here. You can just click in it once and it says items to fillet. And then you can take your mouse out on the screen and you're going to try to select an edge from the screen. So we're going to select this edge here. Now you'll notice that the edge is at the intersection of two faces. So this is a face here. And if I click on that face, it gets added to this list here, face 1. Well, the easiest way to get rid of that is just to click on that face again. A lot of times what I see people do is they click an edge, they click a second edge, and then they accidentally click a face, and then they press escape. And you can try this now if you want. You can press escape, and you can see what happens is you get totally kicked out of the fillet command. The fillet was never created over here in the tree. So you're totally kicked out of the fillet command, so you have to start all over again, fillet. Now, SolidWorks does tend to remember what your settings were, so it does remember we had an 8mm radius here, but now you have to start all over again. So if you click an edge, and then you click another edge, and then you accidentally pick a face, it's okay. Just pick the face again. Currently, it says edge 1, edge 2, and face 1 in the box. Just click a face again, and there you see that that face is removed from the list. So we pick this first edge, pick the second edge, pick this third edge over here. And now for our final edge, what we're going to do is we're going to click right through the part. This is pretty cool. If you take your mouse up here to where you know that edge should be, where you know that edge exists, you can actually pick right through that face of the model, and you can pick that edge there. Now, if you do it wrong and you happen to pick this face, what do? You just pick it again. But if you can get that edge there in that back corner, it saves you from having to rotate the model, and that can be a pretty nice time saver as you're navigating through your larger and larger models. So we get those 1, 2, 3, 4 corners selected, 8mm fillet. We hit the green check mark, and this part is really coming together. So for our final feature, we're going to use this command here. Once again, on the Features tab, we're going to use this command here. It's called Shell. And Shell is a tool that you use to hollow out your models. Now, if you are not sure what SolidWorks is asking for in the Property Manager, here we see the Property Manager again. If you're not sure what SolidWorks is asking for, sometimes you can hold your mouse over the icon in the property manager. And here you can see that it's asking for faces to remove. And then this is asking for the wall thickness. So in the wall thickness box, we can type in, you can double click there. We can type in 1.6. And then here where it says faces to remove, you can take your mouse out here on the screen and you can just click on this face here, and then you can come over and you can click the green check mark. So now that face will be removed. The top face of the model will be removed. And when you hit the green check mark, boom, there you go. You've got the rest of the model. So this thing is looking pretty good. We modeled up the part using our CAD system. We used millimeters. We used millimeters as the units. We added all the features that were on the print. We used all the correct dimensions. So this is looking pretty good, but now we need to assign a density because our goal here is to calculate the mass of the model, and the mass is going to be based on the material density times the volume. So it's asking us to assign ABS. Let's first just take a look at how we add materials to our model. So if you come over here to the tree and you right click on this box here that says material, this is in the feature tree, you can right click and you can choose, let's say plain carbon steel. These are our material favorites up top here. So if we say plain carbon steel, and then we go to this tab here that says evaluate, so you click a different tab here, evaluate, we can choose mass properties. So evaluate mass properties, and we're coming up with a mass of 30.1 grams. So let's go over to the app and let's see if that is correct. So the mass here, 30.1, enter. And it says, nope, that is incorrect. Your answer 30.1 is not within the specified tolerance. The clock is still running, so please continue trying to solve. Okay, so the clock is still running here, so we didn't get it correct, 30.1. Well, the reason that's not correct is because we're using the material density of plain carbon steel, and the drawing, or the customer, wants us to use the material density of ABS. So we close the mass properties box, we come back over here to the materials, we look at our favorites list, and we don't have ABS here in the favorites list. We have ABS PC, but we don't have ABS. So what we can do here is we can say edit material. You right click here on the material or on plain carbon steel. You say edit material, and this lets you access the entire library of SolidWorks materials. So there's an entire library here of SolidWorks materials. You can see you've got SolidWorks DIN materials, SolidWorks materials, sustainability extras, and custom materials. We're going to go into the SolidWorks materials, and then we're going to go down through this list here of categories. We'll go to plastics, and oh, here it is, ABS. So if you look at the mass density, you can see ABS has a mass density of 1020 kilograms per cubic meter. You can see that ABS PC has a mass density of 1070 kilograms per cubic meter. So it's not that far off, but it is a little bit off, and it might be enough to set your part out of tolerance. So you really want to pay attention to the title block, to the specifications from your customers. And in this case, the customer is saying, let's use ABS from the default library. So we say ABS, apply, and close. And then we're going to go back in here to mass properties. And here we see that the mass property is 3.94. I'm just going to copy that. And then we're going to go back to the app here. And in the app, we're going to type in that answer or paste in that answer, 3.94, and enter. And oh yeah, we did it. We got it correct. So 3.94 grams is correct. And our time was 19 minutes. That's a little bit on the long side, but maybe I could go back at some point and try this one again and see if I can get a better time. But if you like those kinds of challenges, this is where you could go to register for a free TooTallToby account. And that way you can take more of these challenges. You can sign up for a free account. You can access some more free challenges. You can even sort them by difficulty level. So you can kind of start out on the tier 1 challenges and then work your way up. So that is the tutorial for that part, and I hope that you learned a lot from that tutorial. But there is one little bonus that I just wanted to share with you, and that is if you did want to 3D print this part, what you need to do is get this geometry into a 3D printer slicer. And if you're brand new to the world of 3D printing, then you're probably just going to use the slicer that ships with your printer, that's by the same manufacturer as your printer. So for example, I'm using a Prusa 3D printer, and this is the Prusa slicer. And so you see here that what the slicer lets you do is it lets you pick the printer type that you're using. Like if I was using a Prusa Mini, then I'd have a smaller bed here. Or if I'm using a Prusa MK3S, then I'd have a larger bed here. here. So you choose the type of printer that you're working with, and then you need to get the geometry from your 3D CAD into your 3D printer slicer. So the easiest way to do that is just to save the model as an STL. And there's another very common format, which is 3MF, and that's a more modern format, and that works fantastic as well. So you could use either. I'm just going to do it as STL because it's just a little more universal. Honestly, it's a lot older, so it's more antiquated. It's not as capable as 3MF, but it's a little bit easier to demonstrate as well. So I'm going to go in here to SolidWorks, and either I'm going to go to File Export, or I'm going to go File Save As, depending which version of SolidWorks you're using. And then I'm going to save this as an STL. And in SolidWorks, when you choose to save the file as an STL, there's a button here that says Options. And from that Options, you can control this slider here. This is going to control how many polygons are in the STL. And I usually move this over to like between 80 and 90%. That gives you a pretty good result. If the STL is too coarse, then your 3D print is going to be like jagged instead of having a smooth corner. So I'm going to move this over in this direction, about 80, 90%. I'm going to say OK. That's a deviation slider. And then I'll call this hollow box.stl, and I'm going to say save. And there you see what those corners look like. See, if I had used that more coarse setting, then these might have less striations in them. So it'd be more like a hexagon instead of a rounded corner there. And so I'm going to say yes, save that off as an STL. And now I'm going to go back into my slicer here from my 3D printing manufacturer, and I'm going to drag and drop that STL in. And so there you see, that's kind of the step to go from SolidWorks to your slicer from your 3D printer. Okay, if you're brand new to this world, I hope that this helps you, because now you can actually 3D print this part, and you can see what it looks like. Maybe you just got your first 3D printer, and so this will be good for you to kind of know what this looks like. The one thing I'll say here is that you can orient this part. So you see that you can rotate this part here, and then you get these XYZ rotation tools. And the reason you're going to want to do that is because if you print it like this, you're going to have to print out a bunch of support here to support this face up here. You can't just print this face here in open space. So you're going to need to support that face. But if you rotate the part, and a lot of times your slicer will have a tool that lets you pick a face and just drop that face on the bed. So there I use this tool here, place on face. But if you're using a printer from a different manufacturer, your slicer is going to be a little different. But now you can see that part's just resting right on the bed, and now I don't need any support. So I can just print it just like that right on the bed. In your slicer, a lot of times what you'll do is you'll say slice now, and then you'll export a file. So you'll take this file, and then you'll save it and put it onto an SD card, and then you'll take that over to your printer. Well, when you do that slice, you'll often get an estimation of how long it'll take to print. So in the current size, it'll take 26 minutes to print. If you wanted to make one that's a little longer so it fits in your drawer, or a little bit taller so it fits on your desk better, you can do that. It's just going to take a little bit longer to print. So I hope that gave you everything that you needed to get through that very first challenge on the TooTallToby website. If you enjoyed this tutorial, be sure to let me know down in the comments what you liked about it. Be sure to hit the like button. And if you enjoy these types of CAD challenges, be sure to sign up for a free account on the TooTallToby website. And I want to welcome you to the TooTallToby community, and good luck on your 3D CAD journey.